Okay, so today I'll be solving yesterday Leetcode daily problem. It's so the basic idea there is the question is I have a grid and I have a path that can go from the current cell. I can go to the either to the right or to the bottom cell, and I need to find all sums of the passes that go from the top left cell to the bottom right cell, and that have sum of the values on the trajectory divisible by k. So having this array 5, say we have 5, 2, 4, 3, 0, 5, then 0, 7, 2, and then in this case k is equal so k is equal to 3, and I need to find the passes like from this cell to this cell that has some number of passes that have some of this all the values on the path divisible by 3. So the idea here is basically have remainders of remainders of mod 3 division, and have that number of passes, let's say for the current cell, I can go into that from top cell and from the left cell, and then when I'm adding the value that's in the current cell to the whatever number of say we have k let's say left 0, that's the number of passes. So this cell, okay, so this cell has left 0 passes. It's equals the number of passes that lead to this cell, and that has a remainder of 0 when divided by mod k divided by 3, and then it has L1 passes. This is a number of passes that has that land on this cell, and that has a sum of the values divisible by mod 3 equals 1, and then I'll have L2 passes that have like, so basically ls equals num of passes that have sum mod k is equal to s. And then I have this top cell that has let's say t0, t1, and t2, and there's also like number of passes that land on this cell, and say for the t0 that has like sum of the values along the path divided by mod 3 equals 0. So in order to derive this value v0, v1, v2, I have to have a formula. Let's say v0, it's again number of passes that land on the on this cell that have like sum of their values divided mod 3 equals 0, and this basically equals number of passes that has let's say I have So it's hard to predict because like it depends on value, yeah. So it's more like easier to find like something like this. V, let's say remainder, let's say remainder gonna be this value t 0 plus, so like I have to do 0 plus val mod k so that it's equal 0, and if it's equal 0 then or this can be v if it's a yeah, it's a hard to show it like in a, so basically what I need, let's say we have a real number, so we have 7, say initially I'll have like I need to fill up initially like for the 5, so initially for the 5 I have one path that has mod 0, mod 3 equals 0, no, actually, if I divide 5 by 3, it's gonna be 0, then 0, and then 1 for the 5. And then for the 2, I need to go, so on 2 I can land from 5. So it's gonna be, if I add mod 2, if I add remainder 2 plus 2, it's gonna be remainder 1, so it's gonna be 1 here, and then 0, 0, and then on the, if I go to the to 3, if I add mod 2 plus 3, it's gonna stay mod 2. It's gonna be 0, 0, and 1. And then if I continue doing that exercise, so for this 0, I can land either from the top or from the bottom, or from the left. And here I can have, if I add remainder 1 plus 0, there's going to be one path that has remainder 2, and then one path that has the remainder 1, and 0 path that has remainder 0. And then for the 4, I'll have this, if I add 4 to the remainder 1, it's gonna be remainder 2. So 1, 0, 0, because let's say 1 plus 4, and then mod 4, mod 3 is equal mod 2. So I just carry this one to here, to the remainder 2, and then to get the, for the 5, I can go from the top. So if I go from the top, it's gonna be remainder 2 plus 5, and gonna be 7 mod 3, and gonna be 1. So I have 1 here, and from here I have this one, so 1 plus 5 gonna be 6, so this one 1, and then 2 plus 5 gonna be 7, and then 7 gonna be 1, so 1 plus 1 here, and then here 0, so this one becomes 2. And then I need to derive this this vector for the cell, for this 0 cell, and I can go to this cell from the top, and when I add it, so it's gonna stay the same. 1 here, and 0, 0, and next I need to figure out the values vector for 7. It's gonna be, so I can go from the left cell to it. So if I get +7, so this one moves to the middle part because no, actually not to the middle part, but 2 + 7 to this part 1, and then 2 + 7 equals 9, and 9 mod 3 equals 0. And then if I calculate those, so it's gonna be, for this one, it's gonna be so 1 + 7 gonna be 8, and it's equal mod 3 is equal 2, so it's gonna be 1, and this one gonna be 2 + 7 equals 9, and that means that this one is added to the first position. So it's gonna be 2 here. And next I need to figure out what the final vector for this bottom right cell, and it's gonna be, if I have 0 + 2, it's gonna be 2, so it's gonna be 1. For this one, it's gonna be 1 + 2, so it's gonna be 3, so 2 moves to this place, and then I don't care about 0. And here 2, so it's 0 + 2 equals 2, so here +2, and this one 0, I don't care, and this one 2 + 2, and this equals mod k equals 1, so this one moves to this part. So the final vector 2, 1, 3, and I need, because I'm interested only in the passes that has some divisible by number of passes that have some divisible by 3, so I'm only interested in this number, so the result should be 2. So if I have that, let's say I have a vector dp I j minus 1, and then let's say I have kk, let's say I have like s here, and then I have a vector dp I minus 1 j s. So I need to figure out, okay, what's it gonna be dp ij and say s equals sum of the dp I j minus 1 let's say s1 plus dp I minus 1 j s2, where I say that s1 is equal I say s is equal s1 plus vij mod k, and then s is equal also s2 plus vij mod k. Yeah, something like this. And this is a formula for the for the solution. And then if I know this formula, I can basically calculate from the left to right, like this, from left to right, and from the top to bottom. And essentially, I can like hold this matrix, or I can even hold just a previous vector, like previous row, like this. So if I need to calculate the, let's say this cell, I need to have the previous row same column, and I need to have current row previous column values, or like vectors. It means that I can have like a previous row, and I have a current row of like basically a vector, vec previous and vec current, and as soon as I finish filling up this vector, I can swap. I can put assign vector current equals vector previous, and then start forming a new vector. And then eventually I need just the last value for the vector at the first kind of component to output. So let me try to solve this. Let's say we have let like rows equals len grid, and then calls equals len grid 0, and then I'm gonna go dpi. So I'll have this array 0. So and essentially I also need to have this mod equals 10 to the power of 9 plus 7, because like number of passes should be it can be very large, so I have to do mod this number, and the output should be like returned as modulo this number. I'll have column. So first of all, I'll have k remainders, and then I'm gonna go and do following. I'm gonna go multiply by k, and then for say for j in range calls, and then for I in range rows, and then I'm gonna have this dp array, and for I in range call rows for j in range calls, and then if I is equal 0 and j is equal 0, I need to just populate dp I j, and then here val. So I'll have this val is equal grid ij, and then val mod k equals 1, and then if I minus 1 greater or equal if say j like I minus 1 greater or equal 0, I need to have this dp I. So it's a new kk okay, for kk in range k, go new kk equals equals previous kk plus val mod k. It's called car k. New k and car k. So the car k plus val and then mod k. And then I need to say, okay, dp ij and then new k equals dp, so I need to do incremented, equals the value itself plus dp I j and then car k, and then I need to do the mod and then here if j minus 1 greater or equal 0, new k is equal car k plus val, and then mod k dp I j new k equals dp. Oh, here actually it should be I minus 1. So here plus dp j minus 1 new k and then I need to do modular mod, and then in the end I need to return dp rows minus 1 calls minus 1 and then 0. So this should be the algorithm. So the new k is gonna be car k that I have plus value mod k. So it's going to be a new remainder, and a new remainder equals the new remainder plus previous remainder, number of trajectories for the current new k plus number of trajectories in a car k. And I basically assume that I'm revisiting this quite a few times and like incrementing. So I have this current value plus and then mod. Then at the end I'm returning the result. Yeah, that's interesting why it's not matching. It seems like every time I solve this problem, it's not matching. It's a new bug somewhere lurking. Why it's not matching this time? Okay, the only I would print and then print here, and then I'm gonna go for basically do the same logic here. For then I have for this one loop, and I'm just gonna go and print the brackets, and then end the call, just empty line, and here print this bracket, and then print dpi j and f dpi j, and then car key, and then I'm gonna have this comma, and then in the end I'm gonna print this one. Oh no, and the call this empty line, or like, yeah, empty string. So what's not matching? 0, 0, 1, 0, 0, 1, 0. So this one is not matching. For whatever reason, whenever I add 2, so here I have mod 2, and then it should be here. So this one, if j minus 1 greater than 0, new k should be, say for the new k, the car k is equal to new k gonna be 2 plus 2. New k gonna be 2 plus 2, so it should be mod 3 should be 1. Where is the error? That's a good question. I minus 1, j minus 1 greater than or equal to 0. Car k plus val is equal to grid ij. Ah, oh no. Okay. No, not really. DPIJ new K. So let's trace it. So in this case, I'll have this car K in range K. So let's say I have car K is equal to, say this one, new K is equal to plus a value two plus two mod K. Okay, mod K. 2 plus 2 mod K should be 1. So the DPIJ DPIJ val mod K is equal 1 here. It should be executed once. Yeah, it's executed once. And then new K, if I is equal 0 and j is equal 1, then I'm gonna have this print f if I is equal 0 and j is equal 1, I'm gonna print new K. E is equal new K. Ah, okay, I see the error here. So basically I messed up that. Yeah, and as I said, what time is it now? Yeah, as I said, this can be improved with just, instead of like saving this as a, instead of like, so current space complexity is or of rows by calls by K, but I can reduce the space complexity and the time complexity also, and this is 10 to the power of 4 in case actually is guess 100 maximum, case 51 maximum. So this total is 25 to the power multiplied by 10 to the power of 5. But there's gonna be time, and then space is the same. So I wanna reduce the space in this case, and in order to reduce the space, I want it to have to be like something like this, of calls by k. And in order to do that, I will do the following. I'll do that dp gonna be actually just this vector, and every element of vector gonna be the remainders. So it's gonna be calls by k space, and then every time here I'm gonna have the new dp. Let's say it's gonna be the same new dp, and then I'm gonna form this new dp equals, and then here new dp equals new dp plus dp, and then here new dp equals dp, and then I don't need this I here. So for the previous column, I just needed to have this new dp also here. And for the previous row, I need just to have dp. And then I'm gonna have this dp equals a new dp. Actually, because I'm something like this, a new dp equals new dp comma dp. No, not really. It doesn't work. Let's allocate it here. And then I'm gonna have this just dp equals new dp. No. I needed to be like here. Yeah, a little bit better. Let's continue. Let's move back to this logic. New dp, reassigning new dp equals new dp dp. Why this doesn't work? because here I need to basically I'm rewriting because I'm re-adding it. I need to somehow nullify the values. So I can move this one into here, and then I can do the following: new dp I j gonna be new k is equal to 0, and then I'm gonna remove this one. Int what? Ah, okay, dp no I. Not really. So because like new k, I'm overwriting the new k. So I need to basically do for I so let's say car k in range k. I need to do new dp j k or like car k is equal to 0. Yeah, didn't bring much improvement. Let's check what's going on here. So it seems, oh, it's still the same. Whatever, that's gonna be it.